All right, I'm going to do the problems 5, 6, and 7 in this video from lesson 101D. Like I have been showing you in the previous problems, in these problems we are mixing all the rules, exponent rules or laws of exponent, okay, all of these rules, all right? And like I said before in the previous video, there are many ways of doing this, but I'm going to show you the way I do it, which I think is easy. Okay, that's my opinion. So here is the strategy. Here's problem number 5. Problem number 5, it looks like a fraction, but this fraction has parentheses on the top. I also see the 13, the base 13 repeated on the top, and they are multiplying. So here we go. So first thing I like to do is to get rid of parentheses. I don't want parentheses. So here is the parentheses. I want to get rid of it. I see inside the parenthesis, I only have one base. When I only have one base and there's an exponent outside the parenthesis, I'm applying this rule, the power of a power, which basically says, now let me keep the bar, let me keep the 13 to the 5th and the 13 to the 10th power, okay? I'm only simplifying, I'm gonna work only with a parenthesis. So every time you have a base inside, only one base inside the parentheses, what you do is you keep the base. I'm going to keep the 13. And what you're going to do with the exponents, I'm going to multiply. That's what this rule says. And 10 times negative 3, do it in the calculator if you have to, is negative 30. So I eliminated the parentheses. The next thing I want to do is eliminate any repeated bases. And you can see on the top, I'm going to change colors. I had the 13 repeated twice. See the base repeated twice. So what I'm going to do, I'm going to keep the bar. I'm going to keep the 13 to the 10th power on the bottom. What I'm going to work with is what I highlighted in green. And you see that I have 13 repeated, the base 13 repeated. And because they are multiplying, I'm going to have to apply the product of a power, which basically says when you multiply two powers with the same base, keep the base. So here I'm going to keep the 13. And what you're going to do is you're going to add the exponent. So negative 30 plus 5. Use the calculator you have to. That's negative 25. And look, I got rid of the repeated bases on the top of the fraction. Now, you can see I have the 13 still repeated, but this time I have the fraction bar. That means that I'm dividing. And when you're dividing, you're going to apply the quotient rule. Okay, that says, remember, fraction is a division. When you're dividing powers with the same base, you're going to keep the base. So I'm going to keep the 13. And what you're going to do is you're going to subtract the exponents. So I'm going to subtract these two. Careful when you subtract in the calculator. You're going to subtract negative 25, take away 10, and that will give you negative 35. Put it in the calculator like I wrote it, okay? And I also told you that when your final answer has negative exponent, you cannot leave it like that. So we're going to apply the negative exponent rule. And remember that this rule says you're going to take the base and flip it, okay, and give back the exponent but positive. But so you understand what I mean flip, 13 can be written as 13 over 1. If you flip that, that's going to be 1 over 13. And give back the exponent, 35 to the 13, but positive. And that's your final answer. Don't try to do it in the calculator. You're going to get a really, really small number. That's all what you have to put there because they're asking you to generate an equivalent expression. Okay? And that was problem number 5. Let's go to problem number 6. So in problem number 6, we have this. We have a fraction bar, 7.3 to the 3rd power, 7.3 on the bottom, the fraction to the 9th power, time, now we have a parenthesis, 7.3 to the 8th power, time, 7.3 to the negative 10 power. Okay, so like I had said before, I like to eliminate parentheses first. That's why I'm gonna work with this inside this parentheses. Okay, that's what I'm gonna do. So when I work with that, if you look inside the parenthesis, I had 7.3 repeated twice. 7.3 is the base, and they're multiplying. So that means that we are gonna apply this rule right here. The product to power. Let me put it over here so you can see it better. Product to power, which basically says when you are multiplying powers with the same base, you're going to keep the base. I'm going to keep the 7.3. And what I'm going to do is I'm going to add the exponents of the bases that are the same. So 8 plus negative 10, do it in the calculator, you have to, is negative 2. So I got rid of the parentheses. Now let's work over here. Now I'm going to work with this. I see this fraction bar. That means that we are dividing here these two bases that are the same. And using the quotient rule, a quotient of a power, okay, the rule said that when you're dividing powers that are the same, you keep the base, so 7.3, I'm going to keep it, that's the base. And what you're going to do with the exponents, you're going to take the 3 and the 9, and you're going to subtract them. So 3 minus 9, that will be negative 6. Okay? The next thing I'm going to do is, I hope you notice, we have a repetition here again. 7.3 is repeated twice, the base. And because we are multiplying, we're going to apply the product of a power that says that when you multiply two powers with the same base, you keep the base, so 7.3, I keep it. And what you're going to do with the exponents, okay? The negative 6 and negative 2, you're going to add them. So negative 6 plus negative 2, it will be negative 8. Use the calculator if you have to, all right? To do these computations. Now, like I mentioned before, your final answer cannot have a negative exponent. I'm going to apply the negative exponent rule now, okay? Which basically says that you're going to take the base and flip it. But before you flip the base, let's write this decimal as a fraction, putting a 1 under. Flip it. So flip 7.3 over 1 to 1 over 7.3. And give back the exponent to the 7.3, but positive. Okay? And that's your final answer. Don't simplify. You're going to get a really small number. Let's go to the next problem. Problem number 7. Now, this problem number 7, is kind of challenging. We have parentheses, but look, we have two different bases. Now, the cool thing is that the two different bases, they are repeated also. Okay, so watch. This is what I'm saying. So let me write it down first. So we have parentheses, parentheses, inside the parentheses, 15 to the 0 power. When you see two numbers together like you see there, that means times 11 to the 8 power over 15 to the 6 power times 11 to the 9 power, close the parenthesis, times, now we're going to do the other parenthesis, 15 to the 5th power times 11 to the negative 6 power, close the parenthesis, the whole parenthesis is raised to the negative 7 power. Like I told you before, I want to eliminate the parentheses. Okay, so I'm going to start with this parenthesis. I'm going to highlight in yellow. Well, let me highlight the parenthesis. I want to eliminate this parenthesis. Now, to eliminate this parenthesis, look inside. I hope you see a division. Okay, you see the fraction bar. That's division. Now, we have two different bases. Here's what you're going to do. When you have two different bases, these rules only work, not these one, I should have said, these rules, the product to power of power and quotient of power. These two rules only work when the bases are the same. So inside here, I have a division. So what I'm going to do is I'm going to work with the bases that are the same. So I'm going to work with the 15, the base 15 first. And using the quotient rule, because I have a fraction, that's a division problem, okay? What I'm going to do is I'm going to divide, I'm going to use the quotient power. And the quotient power says when you're dividing two powers with the same base, you keep the base. I'm going to keep the 15. And you're going to subtract the exponents. Okay, now I forgot what was the exponent on the top. Oh, 0. So I'm going to subtract the 0 and the 6. So 0 minus 6, see? And when you do that in the calculator, you're going to get negative 6. Okay, I did the 15. Put the dot for times. See the dot that I have here. Now we're going to work with the 11. So these 11, see? And what we're going to do is, since you're dividing also powers with the same base, you're going to keep the base. I'm going to keep the 11. And what you're going to do with the exponents, you're going to subtract the exponents, 8 minus 9. When you use the calculator, that will give you negative 1. Look, I'm done with that parentheses. Now I'm going to work with this next parenthesis, the one that I'm going to highlight in fuchsia. Okay, so this parenthesis right here. All right, and I hope you notice, let me take it out because it's too thick. I hope you notice that inside the parentheses, I had two different bases. Each one has an exponent. And on the outside, there's another exponent. And that will be this rule right here, the power of a product, this one. Okay, that's the rule that I'm going to use. And how do you do that? Here's what you're going to do. You're going to give the exponent negative 7. You're going to give it to the first power. So I'm going to have 15 to the fifth power. All of that raised to the negative 7 power. Times, and now you're going to get the negative 7 to the second base here. 11 to the negative 6 power. So you're going to have 11 to the negative 6 power. All of that also raised to the negative 7 power. Okay, I apply this rule right here. That's what it says here. Now, I still have parentheses. I told you I don't want parentheses. See, I had these parentheses. Let's work with the first parenthesis that I highlighted in yellow. This one. And this here, I only have one base inside, and there's two exponents. That's this rule right here, the power to power. I'm going to do this, which basically means you're going to keep the base that you have inside the parentheses, and you're going to multiply the exponent. That will give me negative 35. That's for that parenthesis. Time, I'm going to do the same thing for this second parenthesis. I'm going to keep the base, and I'm going to multiply the exponent. That will be negative 42. Now, what happened with the numbers I wrote in red, I'm going to keep them because I haven't used them yet. So I'm going to write them again. Okay. And we got rid of all parentheses. Now, what I'm going to do, if you remember, the center dot means times. I'm going to multiply powers with the same base. So this 15 with this 15. I'm going to keep the 15 because I'm applying the product of a power rule. This one here. I'm going to keep the 15, and I'm going to add the exponents of the 15. Negative 6 plus negative 35. Do it in the calculator. You have to. That will give you negative 41. And then I'm going to do now the other bases that are the same. The 11s. You're going to multiply them. I'm sorry. They're multiplying, I should say. But by the product of a power, you're going to keep the base. I'm going to keep the 11. And what you're going to do is you're going to add the exponents. So that will be negative 1 plus negative 42 is negative 43. Now, what are the 15s and the 11 doing to each other? They're multiplying, okay? That's the dot that you see there. Now, like I told you before, you cannot leave your answer with negative exponents. So we're going to have to apply now this rule right here, the negative exponent to each one of these, okay? So remember, I'm going to start with a 15, all right? So 15 is like over 1. When you have a negative exponent, you flip it. This will become 1 over 15. And then get back the exponent by positive. Times, we're going to do the same thing with the 11, okay? So we're going to put this over 1. We're going to flip because it has a negative exponent. So this will be 1 over 11. And get back the exponent but positive. I think I forgot here. Negative 1. Yeah, negative 43. I forgot to put that. So let's get back the exponent 40. Get back the exponent of the 11. Let's give it back but positive. And finally, we're going to multiply these two. And how do you multiply these two? You just multiply the top with the top and the bottom with the bottom. So when you multiply 1 times 1 on the top, you get 1. And when you multiply the bottom, basically you're just going to write them. So 15 to the 31st power times 11 to the 43rd power. And that's it. Don't simplify this in the calculator. You're going to get a really small number, okay? And you're not going to type that. What they ask you to do here is to generate an equivalent expression. That's what you're going to do, all right? I hope this helps.